Hi, in this sequence of videos I'm going to go over the AQA Mechanics 3 June 2011 exam paper. When you're watching these videos, if you can remember to try the questions yourself first, work through the answers as you watch the videos, and if at any point you feel that you can finish off a question, you want to pause the video and see if you can finish it off yourself. Okay, so to start with, we're going to have a look at question 1. So in question 1, a ball of mass 0.2 kilograms is hit directly by a bat. Just before the impact, the ball is travelling horizontally with a speed of 18 meters per second. So before we've got the ball, and I'll put the mass inside, so 0.2, and it's travelling with a speed of 18 meters per second. Okay, just after the impact, the ball is travelling horizontally with speed 32 meters per second in the opposite direction. So after, we've got and it's this time going to be going in this direction, 32 meters per second. Okay, so for part A, we need to find the magnitude of the impulse exerted on the ball. Now remember, the impulse is the change in momentum. So my impulse is going to be equal to change in momentum. But let's just write down what our momentum is. So our momentum before is going to be 0.2 times by 18, which is going to be 3.6 kilogram meters per second. And our momentum afterwards is going to be, well, it's going in the negative direction now, so so we've got 0.2 as our mass times by, and this is going to be negative 32, which gives us negative 6.4 kilograms meters per second. So our change in momentum is going to be, but it's going to be 3.6 take away negative 6.4, so it's going to be plus 6.4, and that gives us 10, and our units here are going to be Newton seconds. Okay, so that there is going to be the magnitude of our impulse. Okay, part B, we're told that at 20 seconds after the ball first comes into contact with the bat, the force exerted by the bat on the ball is given by this expression here, where k is a constant and our time is between 0 and 0.09 seconds, and that's how long the bat stays in contact with the ball. Now we know that the impulse is going to be equal to, and it's going to be the integral of our force, and we also know that our impulse is actually 10 Newton seconds, and because this is, our limits here are going to be between 0.09 and 0, which is the full time that the bat stays in contact with the ball, I can say, well, the integral of f, which is, and I'm going to take this k outside here, and we're going to have 0.9 t take away 10t squared, between the limits of 0.09 and 0. Well, I know that this integral here has to be equal to the impulse, which is 10. Okay, I can then carry this on now, because I know that k times by, and if I integrate this, I'm going to get 0.9t squared over 2, take away 10t cubed over 3. So our limits of 0.090, and we know this has to be equal to 10. Right, so coming over here, well, if I now sub in my limits here, obviously when I sub in the 0, this is just going to be 0, so I'm going to have k times, and I'm going to sub in my 0.09, and if I work that out there, I have 0.003645 take away 0.00243, and so that's that in there, and that's going to be equal to 10. So working this out here, I've got 0.00115k is equal to 10, and divide both sides by this, and I get k is equal to, and it's 8,230. Okay, and that's to the nearest whole number. Right, okay, so so that would be 4 marks for that. Hopefully you found that clear. Thanks very much for watching. I look forward to seeing you again soon.